Hi, in this video we're going to cover how to write the basic elements of a linked list. So most programmers are familiar with lists, and specifically in Java the list interface and all of its the implementers of the list interface. So here I have a web browser open where I look at Java 8's documentation on the list interface, and we can see there's many different types of lists. There's linked list, row list, stack, vector, array list, which is the probably most commonly used these days. So we're going to pretend like we don't have any of these libraries available to us, and what would it take for us to begin developing a list from scratch. And some of you may be asked to do this in a homework assignment in school, so we're not going to cover everything. We're just really going to start and lay out the skeleton for the implementation and write a little bit of the add method. We want to add something to our list, and I will leave it to you as an exercise to implement other interesting methods like remove and things like that. Okay, so let's jump right into it. So let's create a new project. It's going to be a Java project. We're going to call it simple linked list. Okay, and here, new Java class. We're going to call simple linked list, and we're going to use generics here because we want to support a linked list of integers or strings or anything else. We don't want to bound ourselves to one particular type, and of course we don't want to be completely raw and unbounded, so that's why we are using the generics feature in Java here. And so right, so let's start by introducing the a static inner class here. That's going to be our linked list is going to depend on static class called node, and the node will be of the same type as the enclosing class, right? And the E really is the data that we're going to capture inside of the container. So we're going to say private E data and private node next node. Let's just call it next. Okay. So we're going to have a constructor that's going to take some kind of data. Let's say it was a string. We're going to say this dot data is equal to data. And we're going to have a method on here that returns a node that get next. And we're going to need a set next. Finally, having a toString method would be nice, and we'll just print the data out when we get that. Right. Okay, so that is the node that we're going to introduce. Okay, and that's really what we're going to depend on in order to construct our list. So for our list, we're going to keep track of 3 member fields. 1, the head of the list. It's like the first item in the list. And another one is the tail of the list, right? The very last item in the list. And finally, we need to keep track of the size. We don't get that for free, right? And so let's start by writing some methods on here. And so the most important method that we want to write on here is add public void add edata. And you might want to pause the video at this time and take a stab at doing this yourself. If you're wondering about how you would go about making your own list and then adding items to that list. Okay, let's jump right in then. So in here we'll say final node of E new node is equal to new node. We're going to create a new node and we're going to wrap the data in that node. And we're going to say if the list is empty, there's really only two cases here. If the list is empty, right? We haven't written that method yet. All we have to do is say this dot head is equal to new node, and this dot tail is equal to new node. Very simple scenario. Okay. Otherwise, if the list is not empty, then this dot tail dot set next. We're going to add it to the end. That's the first element after the tail. Right? We're going to set that, which currently is probably null. Not probably, it is null. We're going to say we want to set that to the new node that we just created. We created a method called set node or set next, so let's use it. And we're just going to say new node. And we're going to say the new tail, now tail, is equal to that node as well. Okay, so we're just going to update that. We're going to update the tail pointer after we've set that node. That's really all we need to do. And here we're going to write a method called public boolean is empty. And we're just going to say return this dot list size is equal to 0, if that's true. Right? Oh, and I forgot, after invoking add, we just need to say this dot list size plus plus. And that should be it, really. The rest of the code that we would write would relate, at least as far as this example goes, to toString. Of course, there's other methods to implement on a linked list, but I want to leave that to you as an exercise. Again, I realize that some students may be watching this, and so I want you guys to take a stab at implementing that. So let's go ahead and override public string toString. This should make your debugging a little bit easier. When you come to do that, we'll say node of E current node to this dot head string builder output is equal to new string builder, right? And while the current is not equal to null, all we want to do is say output dot append, and we'll do that. We'll use sort of a bracket. Output dot append current dot get data. Output dot append closing bracket, and update the current to be current dot get next. Very simple. Return output dot toString. Right? That really is it. And I think we've implemented a very simple linked list, the beginnings of a linked list, with the add method in about 60 lines of code. So let's test it really quickly with the main method. And say here, this should be fairly straightforward. We'll say final simple linked list of string linked list is equal to new simple linked list. And we can say LinkedList.add, C LinkedList.add, spot LinkedList.add, run. And we're just going to say system.out.println linked list, which should invoke our toString method. Okay. There it is, C spot run. Okay, so I just wanted to take a little bit of time to go over some of these things that newer programmers might not understand how they work, but they would rely on them very heavily. Simple sort of data structures. So do go ahead and try and implement the remove method. It's going to be a little bit of a challenge, but it's worth going through the exercise. And I appreciate you guys' time and patience. Please do rate, like, and subscribe the videos if you can. Please share them. And I look forward to talking to you again soon. Thank you.